is going to cover Git. So before we start, make sure that you have Git on your computer. You can check this by doing git -- version in your terminal. And you also want to create an account on github.com or have another Git account that you want to use, maybe one associated with a GitLab through your work, and log into that account. And if you haven't ever set up your configuration for Git through your command line yet, you'll want to run these 3 commands. So the git config to set your GitHub username, to set your name, and to set your email. And that's just the information that'll be used whenever you push or pull from your repo. And all your Git configurations can be viewed in your ~/.gitconfig file. And you can also edit them there too if you don't want to edit them through those command line commands. Okay, so what is Git? Git is a version control system that lets you keep track of file histories and backup work online. So it's a way to make changes and have a history of those changes, so you can go back to previous versions if you want. Okay, so some vocab before we start. Repo, which is short for repository, is basically like a folder within your Git account. And then the local repo is the local version of repo, so it's specific to your computer. And the remote repo is the online version of the repo, and that's shared between all contributors who might be adding to a repository. There's the readme.md file, which contains a description of a repo, and you can format that using a language called markup to get things like bold text and underlines and italics if you want to. And the README is also what is used to show the description that you can see from the Git page for a repo. And then clone is putting a copy of a remote repo onto your machine for the first time if you don't already have that repository on your computer. Okay, so creating a new repo. This is me in GitHub, and I'm already logged in as myself. And I'm going to say new repo. And I'm going to say the owner to me. And I want to name the repository demo. And the repository names always have to be just a string of characters and no spaces. So if you do want to have multiple words, you can either do camel case, so like that, or snake case with an underscore between them. And I'm going to leave my description blank because it's optional. And because I'm paying for my GitHub account, I can have either public or private repos. So with a public, anyone can see it, and I get to choose who's allowed to commit to master, the base version of my repository. Or I can make it private, which is I'm the only one that can see it, and I get to choose who can see and commit to the repository. And the easiest way to create a new repo is to check initialize this repository with README, and that'll automatically create the repo so I can clone it to my computer from the beginning. So I'm going to add a git ignore. So git ignore we'll talk about later, and for right now I'm just going to say none, actually. And there are some licenses you can do that talk about how people are allowed to use your code. That's if you wanted to start something open source or create something that other people might want to use on their computers. I'm also going to leave that blank for now. I'm going to say create repository. Okay, so now I have this repository, and this right here is being generated based on this readme.md. So this is my repo on my remote repo, and I want to get it onto my computer. So I'm going to, in my terminal, going to cd into desktop, and I'm going to hit this green clone or download button. And this is the Git link. So if I go back to my slides, this is the command to clone, git clone, and then the .git repo URL. So I'm going to hit this button to copy it, and then do git clone command V. So now it's cloned onto my computer, And if I go to my desktop, I can see that demo is now a folder on my desktop. So I'm going to cd into demo. And right now, the only thing that I have in here is my readme.md. Okay, so present again. So some more vocab. A commit applies changes you've made on your computer to your local repo. A commit hash is a collection of letters and numbers that's associated with each commit. So every time you make a commit, it records this identifier that's associated with it, so that way you can refer back to that commit later if you need to. Adding marks files as ready to commit, so it moves them to the staging area between exactly what's on your machine and what's on your local repo. A push applies changes from your local repo to the remote repo, and then a pull applies changes from a remote repo to your computer's files. So a pull is helpful if you have two separate people working on the same repo, and the person on computer A makes a change and pushes, and the person on computer B wants to get those changes on their computer. That's when they would do a pull. So .git, if I do ls-a to see all the hidden files, the .git is a directory that is part of what makes this a repo. If I was to delete that directory, it would take what I have on my machine and from a Git repo to just a plain folder on my machine, and I wouldn't be able to add, commit, or push to the repo anymore. So it's like breaking the connection between what I have on my computer and what's on my remote repository on GitHub. .gitignore is a file that for every Git repo that configures some files that should not be committed to the Git repo. It's good for things like notes in the repo you might want to only keep locally, or files associated with an IDE that aren't needed in a repo. For instance, any compiled versions of programming files you might have, that sort of thing. It can include wildcards like an asterisk. So I'm going to open a .gitignore, and I'm going to say that I never want to commit .class files. So I'm going to add in *class and then escape to go back to command mode, and then :X to quit and save at the same time. And now I've told it to just never commit, never even look at .class files as something that can be a part of my repo. Okay, so this is going to be a visual representation of the different levels of a GitHub repo. So there's the code on my machine, and then there's stage. And in order for the code to get from my machine to stage, I do an add. And then there's the local repo above that. And to get from stage to the local repo, I do a commit. And then there's the remote repo, and to go from the local repo to the remote repo, I do a push. And then to go, I can't skip levels. It always has to go in this flow. And then there could also be an arrow from remote repo to my machine for pull. So the basic workflow that you'll be dealing with every time you use Git would be make some changes to files, do an add, and that can happen in a sequence. So I could make some changes and add them to stage, make some more changes, add them to stage, and do that until I'm satisfied with what I have and I'm ready to commit. So then I can go to commit. And I can go from having things added to committing them, back to adding, back to committing. So I can build up things that have been staged and then commit them. And every time I do a commit, I'll get a new commit hash. And then I can keep committing, maybe multiple commits all at once until I'm ready to push. And at that point, when I push, it just takes all of the commits that I've done since the last push and pushes them to my remote repo. And I can't go back again until I've done another commit. And then after I've pushed, I can make some more changes potentially. And then for a pull, after I've pulled, I can make some more changes or push. And I can also pull after I've done some committing. Anything outside of this basic flow would throw an error. So for instance, if I try to push before I've pulled, I'll get an error in my console. And if I try to push before I've committed, and it'll also give me an error. So this is, I know this chart looks a little bit confusing, but it'll make a lot more sense as you get used to working with Git and going through the process of yourself. So this is going to be a walkthrough of the basic workflow. So here are the basic commands for Git they're going to be using. There's git status, and that tells you what's going on with your repo. So it tells me that I have untracked files, which means that they're completely new. They've never been on my repo before, and I've made changes to them. And you can tell that they're untracked because it tells me here, and then visually they're red, which means they're not staged. I can do git diff, which will show changes since the last add. So right now, if I try to do a git diff, I don't get any information because my file is untracked. So something to be aware of, if you have untracked files, when you run git diff, it doesn't have anything to compare them against, so you won't see one. Git add file, so I can do git add.git ignore. We'll put the file into stage for the next commit. So now if I do git status, it's a new file and it's green, and I get told that they're the changes that would be committed. I can also do git add directory, which will stage a directory and all of its files for the next commit. I could also do a git add-p, which will start an interactive session that lets you choose portions to add. Again, this is working off of diff chunks. So if your diff returns up empty, this command isn't going to work like you would expect it to. So let me show you. If I open up .gitignore again, vi.gitignore, sorry, and I make a change, like I don't ever want to do notes.txt, and I do a git status, I see that this has been staged, but there are some changes that haven't been staged yet. So looks a little bit strange that I have green and red for the same file, but these are this right here were when I created the file initially and added, and this is the edits I've made since the last add. So now I can do git diff and see that this plus in green means that I added that line. And if I had deleted a line, I would see a minus with red text to show that it had been deleted. And now I can do a git add-p, and it asks me, do I want to stage this hunk, which is this collection of changes. So I only ever care about yes versus no, and I'm going to go ahead and say yes. I do want to stage it. So now if I do git status again, I just have this one thing shown because I've added another change and I haven't committed yet. So it's squishing them, all of those adds together. Git commit will commit stage files and opens Vim for you to enter a commit message. So I can do git commit. So I had to press I to get into insert mode to enter my commit message. So I'm going to say first commit, exclamation point, dot get ignore file, and then escape to go back to command mode, and :X to save and quit. And now my commit has been made. So if I do another get status, I get told that my branch is ahead of origin master by 1 commit, which means I need to push if I want to put things, my local commits, onto the remote. And then, so there's that. If I make another change, like let's say that I create this example.txt file and put hello world inside of it. Now if I do a get status, I need to add this. So I'm going to get add example.txt and do a get commit-m and say committing example.txt. What that did is it committed the stage files with a commit message immediately without me having to add it in Vim. So now if I do a get status, it tells me that I'm ahead of origin master by 2 commits, and I can use git push to publish my local commits, which is what I'm going to do next. Git push sends changes to the remote repo. So I'm going to do git push. So now if I do a get status again, I get told that I'm up to date and there's nothing to commit. So if I go here and refresh, I can see that my changes have made it onto my remote repo. If you've never pushed before, you might have to do a command that looks like this: git push origin master. So if you get an error the first time you try to push, try doing git push origin master. And that's just telling it where on your Git repo to send the information. So, clear? And then git pull will get the latest changes from the remote repo onto your machine. So I can edit example.txt straight on the GitHub website by hitting this little pencil. And so I'm going to put say changes made on github.com. And I'm going to say remote changes for pull example. So I'm going to commit those changes. So now they're on my remote branch. And if I go back here, I can do git status. And it tells me that I'm up to date with origin master. But I know that I've made changes remotely, so I'm going to do git pull. And I can see that example.txt added 2 lines. So I can do vi, actually I'm going to do cat example.txt. And I can tell that those changes got added from what I changed online. And now the change is on my computer. So clear that again, and that's would be your basic flow. Make changes, add the changes, commit, and then push. And if somebody else has made a change, do a pull. Okay, so now we're going to talk about branches. A branch is an offshoot of a particular repo that's used for making changes without messing up the base files. The default branch for all repos is called master, and any other branches you create are named whatever you want. So if I run the command git branch, it'll give me a list of the branches that are on my current machine, as well as an asterisk next to the one that I'm currently on. So some branch commands are git checkout -b name, which will create a new branch from the current one. So I can do git checkout -b a. And so if I do git branch again, it shows that I'm on branch A. I can create another branch by doing git branch -b b. Oh. Maybe I can't name it B. Git checkout -b b. So now if I do git branch, I just ran the wrong command. So now if I do git branch, it shows I'm on branch B. And because I was in branch A, when I did git checkout -b b, B is branched off of A, not master. I can also do git checkout -b new branch name from an existing branch, and that'll create a new branch off of an existing one. So I can do git checkout -b the C, which will be the new branch, master. So that created C off of the branch master. So now I can use git checkout name to switch to a branch that already exists. So I could do git checkout A, and now I'm on branch A. So let's open up example.txt and add changes on branch A to it. So if I want to tell the difference between two branches, I can do git diff master. And this is the difference that's on, you can tell that I added this on branch A, but it's not on master. So it's a way to tell what difference you've made on a particular branch. Okay. And then if you want to push to a particular branch for the first time, it's git push -u origin and then the branch name, and from that'll do your first push, and then from then on you can just do git push inside of your branch like normal. And until the first time that you push to a branch, it's not going to be shown on your remote repo. So I'm going to go through, so if I do git status here, I can tell that I modified example.txt on branch A. So now this part of the status makes sense. This is the branch that I'm on. So I'm going to do git add example.txt, git commit m first commit on branch A, and then a git push u origin A. It's thinking, and now that's pushed. So now if I do git status, it tells me that I'm up to date. So if I go back to the GitHub website and refresh and go back to the demo homepage, now it tells me that I have 2 branches. And I can go look at that branch information. I can see my branches and what the updates have been. And I can also go back to demo and I can look at the commits that have been made. So it'll show the commit messages, and I can switch between the different branches to see what commits have been made for the branch. Okay, so from here I can do things like look at the commit hash. This is a shortened version of it, and if I hit this button, it'll copy the full one. So that's actually the full commit hash for that commit. I can look at this to browse the repository at that point in the history. So if I do this browse and look at example.txt, I see that the changes on branch A show up, whereas if I go back and I look at the repository at this and look at example.txt, that's no longer there because I'm looking at a snapshot of the repo at a different point in time before I made that change on branch A. So merging branches. This is whenever you want to put changes from one branch onto another. So I'm going to git checkout master. Sorry, git status. So I'm on master now, and I'm clean, and I want to merge the change that I made on branch A onto master. So I'm going to do git merge A, and I can tell that it made a change on example.txt with one file change and 2 insertions. So now, if I look at example.txt, I can see that I have the changes on branch A, even though I know that I'm on master. So the most often, there are 2 main use cases. You either want to merge branches back into master to get all the file changes back into one place. If you have done some experimenting and you like that experiment and you want to apply it to what everybody else would be working with. Or you merge master onto your offshoot branch to get common changes back into your work. So that's merging. And you can get what are called merge conflicts. So that happens when there are 2 different, you both have changed the same file, but at the same place, so that Git can't resolve the differences. So for instance, I'm going to open up example.txt here, and I'm going to make this, I'm going to remove the word branch here, and git add and git commit it, so that way that lets me switch branches. I'm going to say removing branch, word branch. So this is important. You can't switch between branches with uncommitted changes. It'll either move the changes between a branch or give you a warning saying that you need to commit if you're going to switch branches. So now I'm going to do git checkout A. And now I'm going to open example.txt and remove the word changes from line 5. Okay, so now I want to try to do git merge master. Okay, so this is an example of a warning that I get. It's telling me that I have local changes that could be overwritten, so I need to commit them. So I'm going to do git add, and this git add star, what it does is it adds any changes you've made to all of the files at once. So if I had changed 5 files, it would add all 5 files to stage. And then I'm going to git commit remove word changes. Okay, so now I can do git merge master, and I get this notice that I have a conflict. It says conflict in bold, or in all caps, and then says I have a merge conflict and tells me which file it's in. So I need to fix them and then commit the result to make those 2 branches in sync now. So if I open example.txt, this indicates that this was what was on head, so my version, and this is what was on master, what I tried to merge in, and I have to decide who wins in this situation and remove all these extra characters. You can fix the issues manually by editing the file yourself, or use a tool like merge tool to resolve the conflicts. And you would start that like git merge tool, which I don't think, which I have installed. I wasn't sure if I was going to have it installed. I have it installed, but it's not configured. So it always is going to ask me if I want to start resolution. Oh, nope, mine requires Xcode. So I can't show you what this looks like, but basically, I still have the conflict now because my merge tool wasn't able to load properly. But merge tool is a GUI for solving merge conflicts, and it allows you to pick a version, to pick which changes you want to take from which branches. So this is a visual representation of branches over time. So this pink arrow is time moving from left to right. And let's say that I have master, and this is also showing what we just did when creating our branches. We had master, and then we branched A off of master, and from this point moving forward, A and master are going to be parallel until we call merge. And then we branched B off of A, so now master A and B are all parallel, and they won't come back together until we merge. And then we had C was also off of master, and that will continue to be parallel. It looks like A and C might intersect based on the graphic that I put together, but they actually won't. They'll stay as separate things until we do a merge between them. So this is what a merge would do. It would take whatever information is at A at this point in time and put it back into master. And this merge would take information from master and put it back into C. So, yeah. And until this merge happens, so this is what it looks like. Sorry. In this, it's not an exact picture of what we did because the merge to A in this picture happened before C branched off. So now in this representation, C would have the changes that got made in A that got applied to master. I hope that made sense. I kind of stumbled there, but that's what's happening with branches. This is how I visualize branches whenever I'm trying to keep them straight, and I'll tend to draw this on a whiteboard if I get really confused and I've got a lot of branches going at the same time. Or if I'm trying to figure out where information may have gotten lost in my branching and merging and that sort of thing. So some advanced commands. There's git stash, which is a way to save off all changes and reset the files. So let's say that I create a file test.txt with testing. So this is telling me that example has been modified and test.txt has been added and is untracked. And so what I want to do is stash the changes, and that'll put me back to wherever I was from my last commit. So I'm going to run git stash. I've put myself in a bad state to show stat because I have conflicts that need to be fixed as well as the stats. So let me fix those conflicts real quick so I can show an example of stash. So I'm going to open example.txt. And that's how I've decided to resolve the conflict, to just let both of them be there. add example.txt, git, and then I'm going to say git commit fixing conflicts. Okay, so now I have this git status that for this that's not tracking this new file that I made, and I want to be able to switch between branches. So I'm going to say, so now if I try to do git checkout B, I'm on branch B, and test got moved between them, just like I told you that it would. But if I make a change to example.txt, and do a git status, now I've modified example.txt. And if I try to switch to master, I get this warning that my local changes to example.txt will be overwritten by the checkout. So I either need to commit or stash. And I want to stash this time. So I'm going to do a git stash. So it's saved off the working directory. And so now if I do a git status, I still have this untracked file laying around, but my change to example.txt is gone. And if I want to reapply that changes that were saved off from the stash, I can do a git stash pop. And now the example.txt has been modified again. So it's a way to apply, so stash and stash pop are a way to save off and then reapply changes at will if you decide you want them. Or maybe you have a bunch of files and you just made some changes and you think you've introduced a bug or an issue with your file set and you want to make sure that that's what happened. You can stash all the changes you just made, rerun some things, and if you don't get the bug anymore, you can pop and then start digging in to see what you might have changed to mess things up. Okay, so if I do git status, I can still tell that I modified example, and if I do a git diff, I can see that what happened is I added this exclamation point. If I decide that I don't want this change in example.txt anymore, and I want to have it line up with whatever the last commit was, or since the last add, I can do a git checkout example.txt, and then if I do a git status, it doesn't look like example has been modified anymore, and that's because it took whatever example looked like before the last add and used that. Okay, so I'm going to go ahead and remove test.txt so we stop moving it around. And so this is what it looks like if everything is right with the world. Okay. I can also do git reset file name. Sorry, I skipped one. I can also do git checkout and then a commit hash to check out a particular commit. So that would be, let's say that like 3 commits in the past, you like that version, you want to play with that version or see what the code looked like at that point, you could do git checkout commit hash and get that code. So I'm gonna git checkout master. And I'm still ahead, so I'm actually going to do a git push really quick. So now I'm up to date and I'm working on a clean branch. So if I go to demo and then I'm on branch master, I can look at my commits for master. And these are the commits that I've done. And if I want to go back to, say, this version of the master branch, I can hit this button to copy the commit hash, and then do git checkout command V. So now I have that my head is attached at this commit hash, and if I do an ls, I only have example.txt, and if I look at example.txt, it's just hello world, because that was the first thing that I committed. And so now if I do git checkout master, it'll put me back at whatever the most up-to-date version of that branch is. So I'm going to clear that. Okay, so now to do a git reset file is a way to unstage a file. So if I go into example.txt and do change to stage, I'm going to do git add example.txt. So now from the status I can tell that it's been modified, and it's green, so it's been staged and is ready for me to commit. But if I'm not ready to commit it, I can do a git reset example. And now it's unstaged, so if I do a git status, it's red again. So it's no longer a candidate to get pushed to my local repo. Cool. So let's say that I want to create test.txt here now, and I'm going to put testing escape :x. So now if I do git status, I have this modified file that needs to be added and committed, and this new file that's untracked. And I want to add both of them, so I can do git add star, git status. So now they're both green, which tells me they're ready to be committed. And I'm going to go ahead and commit them. So I'm going to do git commit -m more files. And normally you would want better commit messages than this, something more descriptive, so that way you could look back on them and see what you were thinking. If you'll notice on GitHub, whenever I'm looking just at the list of files, the most recent commit message for that file is what shows up next to it. So I can tell that README hasn't been updated since initial commit, and git ignore hasn't been updated since the first commit, and so like that. And having descriptive commit messages can be really helpful in figuring out what the flow of your Git looked like along the way. Maybe I shouldn't have put the exclamation point. Git commit some more files. Okay, so now I have committed that change. And now if I do a git status, it tells me that I'm one commit ahead and I need to push. But if you decide that your commit isn't ready to be pushed, or you need to make changes to it, or you didn't like it, you can do a git reset head caret enter, and it unstages the changes, so I can do a git status. And now these files got taken off of my commit, so off my local repo, and also they've been unstaged, so it's like I never added them. So that can be nice. And whenever you do this command, it will undo all of the commits that you've just done. So if you do multiple commits, it will undo all of them. So let's say that I do a git add for test.txt, and then do a git commit -m test commit, and then do a git add example.txt git commit -m example commit. So now I've done 2 separate commits, one for each file. Then if I do a git status, I can tell that I'm 2 commits ahead of master, but I've decided I want to undo the commits. So I'm going to do git reset head caret. And if I do git status, I'm sorry, I was wrong. It undoes 1 commit at a time. So if I do git reset head again, it'll undo the second one. So git reset head caret will undo 1 commit at a time, starting with the most recent one. Okay, so rebasing a branch. Rebasing changes the branch that the current branch is based off of, and it changes the structure of the branches within a repo. And this is what that looks like. Again, this pink arrow at the bottom is time, moving from left to right. So let's say I have master, and I branch A off of master, and then I branch B off of A. So A is the base for B. And then I decide sometime later that I want B to be based off of master instead. I can do a git rebase, and now B is based off of master instead. And the command for that is git rebase. So I'm going to do git status. And so I have these changes. So I'm going to remove test because I don't care about it anymore. And I'm going to do a git stash. And I want to git checkout B. So now I'm on branch B. And B is currently based off of A, but I want it to be based off of master. So I'm going to do a git rebase master. So this is rewinding your head to replay your work on top of what you did previously. And then it's fast forwarding master to B. So that's the part where it moves master from whatever its previous base was A to master. This can get complicated, and you can have conflicts if you would have gotten like a merge conflict between B and A. So something to keep an eye out for. You'll have to fix conflicts and go through some steps along the way for rebasing if things get complicated, but that's the basic way to deal with a rebase. So forking. A fork is a copy of a repo, and it creates a totally new master to work off of. It allows you to have independence from the original project without worrying that you're going to mess up the original project. So forking is something you might do if there's an open source repository online that you want to contribute to, but you're like nervous about it, or you don't want to ever push to their master, you just want to have your own copy of it to mess with. So that's forking. A visual representation of a fork is, this is the original master, and then at some point you fork and get your own master, and these two will never meet again because you've completely forked and you've completely created a parallel project. So some helpful links are github.com, which is the GitHub website. And then there is this URL, try.github.io, which is an interactive tutorial for Git. It's really good. It's a way to play with Git in a way that you won't have to make your own repo and go through it. It'll lead you through the basic flow of it to get used to it, that sort of thing. And then there's this download site, which will get you some Git GUI downloads if you're not comfortable doing things through the command line. Some people really like GUIs, which is graphical user interface, and some people just really like doing things through the command line. It doesn't really matter which one you do as long as you get comfortable with it. And that's it.